Hey everybody, Dr. Rob Silverman here. I have my esteemed colleague, New York Times bestselling author, Dr. Austin Perlmutter. Dr. Perlmutter, how are you today?
I'm doing great. I'm so excited to be back on the show.
Thanks for coming back. I appreciate you. A lot of people have been asking about you. So let's get right into it. What are you up to?
That's a good question. We could go really anywhere with that. But the area that I'm most focused on as it relates to understanding how we can transform health has been on the brain for a while. And I kind of follow, I guess, in the footsteps of my dad, who's a neurologist, who's been focused on brain health for many decades. And for me, it's really a focus on how our bodies, how our brains are getting stuck, what's happening at a biological, a cellular, a pathway level that is leading us to be trapped in cycles of unhealthy thinking, unhealthy behavior. And one of the areas that has become very clear as it relates to the connection between stuckness and our biology relates to the immune system. I know this is something that you are very steeped in right now, something that all of us have had to pay attention to in the last few years. And it's funny because when you think about the immune system, many people consider it primarily just a defense system, right? So it's something that's going to fight off a microbe, keep you healthy. You can boost it with vitamin C. And yet, what the science would say is that this microbe defense, even though it's an important aspect of our immune health, is just one chapter in the book. And maybe even one chapter in a book in an anthology, which is what the immune system really does. So, what I've focused on is how the immune system is integrated into our brain health, how it relates to our mood, how it changes our thinking, how it changes our behavior, and maybe more importantly, what aspects of the modern world may be influencing our immune system in our brains to keep us unhealthy, and things that we can do, simple steps, hopefully, that will allow us to help program our brain's immune system for better health.
You know, the immune system in the brain is a very personal matter to me. My mom got COVID a couple of years ago. She's
Mm,
elderly, and there was a distinctive, almost like a post-stroke effect, loss of cognition, slurring of the speech, personality change. She was always a very happy, positive person, and now she's angry. She kind of feels
mm.
like she got shortchanged or something like that. So, if you could explain to everybody how the brain affects that mood, I think everybody would be real interested in that because now we're seeing a lot of issues with depression and things of that nature. So, if you could
Yeah, it's a
expand on
really
that, it'd
good
be great.
question. Unfortunately, what happened in your family is not all that unique. What we've seen, generally speaking, around the world is since the pandemic began, a whole lot more mental health issues. And I've been focused specifically on depression. So, depression prior to the pandemic, we're talking roughly 300 million people around the world. But a study came out in the Lancet last year, and it looked at how many additional cases of depression we might be able to attribute to the pandemic. And I want to be clear here, we're not talking just the natural increase in the prevalence of depression we'd expect to see with the population growth. They said that due to the pandemic, we probably have an additional 50 plus million cases
Mm.
of depression, and even more than that of anxiety. So it brings up this question, which is we have this immune event, which is an infectious disease, which is COVID-19. Um, what exactly is the link between this pathology, this virus, and what we're seeing with mental health? And so I published a review paper on this specific subject last year for Frontiers in Neurology. The kind of main takeaway, which I think should hopefully unite people. A lot of people say, oh, it's not about the virus, it's about something else. And then other people say it's 100% about the virus. Well, what I talked about in this paper is this really interesting convergence of pathways in the brain, whereby if you did contract COVID-19, sure, you could have inflammation in your body, and sure, that inflammation could lead to changes in the brain that affect our cognition, affect our mood, but also the lifestyle changes that occur as a result of the lockdown, the increase in stress,
Mm.
the worsening of diet, the decrease in exercise, the loss of interpersonal connection. These are all things that have been linked to inflammation themselves. And so, if inflammation in the brain is a central pathway that links our mood and the other things happening in our bodies, which I would argue it is, then really it doesn't matter exactly whether the insult is a virus or poor food choices or a lack of exercise. You're still getting to those central pathways. There's a lot that we can talk about as it relates to how those neuroinflammatory pathways influence mood. Just to kind of give a teaser, it's thought that neuroinflammation may decrease levels of available serotonin. It's thought that neuroinflammation may damage healthy neuroplasticity. So there's a lot of pathways that tether to kind of these central brain connections that have been linked to how clearly we can think, the quality of our mood, and even our ability to relate to other people, to feel connected and in community. So it is a much deeper subject, coming back to the topic I mentioned before, than just this connection between the immune system is fighting off microbes. No, it isn't. I mean, that is part of it, but there's so much more going on. And I think it's really important that we understand some of these other aspects of the immune system.
I think you made a couple of really great points I would like to unpack. Number one, obviously it wasn't so good if you contracted COVID-19. There were some deleterious effects. However, just trying to avoid it in those lockdown methods or the fear of it also had some damaging effects. And I think that was quite overlooked. You used the term neuroplasticity, which clearly excites me. You know, if your brain can fire together, it can wire together. So I really like you to explicate a little bit more on what neuroplasticity is and its overall effect on the body, and a couple of hidden gems that I know you know about the BDNF and things of that nature.
For sure. I think one of the most exciting discoveries as it relates to brain health is that the brain is plastic. And what that means is that your brain is always changing. So if you think about kind of how you start out, you have billions of neurons, those are brain cells, and then you have trillions of connections between all of these neurons. And you have in the early years more connections than what you have now. And so as you learn, as you refine what you're using, the brain does something called pruning. What does that mean? It means it kind of cuts out connections between certain neurons and it strengthens connections between other neurons. And that's a form of neuroplasticity, meaning your brain is changing as a reflection of your environment. So as we learn languages, as we interact with the world in those early years, our brain is becoming more adapted to our environment, meaning it's better set up for us to manage whatever's happening around us. And for a while, and still I think in many circles, it's kind of assumed that the brain changes a lot when you're a kid, but as you get older, it's fixed. And it does seem to be the case that the brain changes more rapidly in our early years. But what scientists have shown, primarily in animal models, but then also in humans, is that our brains change over the course of the lifespan. And again, there's a number of ways that it can change. One is a change in the strengthening and the number of connections between neurons. So that's talking about synapses, meaning you can create new connections between neurons. You can strengthen or weaken the connections between neurons. That's kind of synaptic plasticity. It's a subset of neuroplasticity. But there's also a part of the neuroplasticity conversation called neurogenesis. And sometimes it's its own little bucket, but I just include it here. Neurogenesis means the creation of new neurons. And this is something that was only recently discovered to occur in human adult brains. What this means is at a very basic level that each of us is capable of creating new brain cells over the course of our lifespans. It's really important. Now, how much does it overall contribute to how much our brains change relative to synaptic plasticity? It's a little bit less clear. And I would argue at this point, it's probably the case that synaptic plasticity, meaning changing the strength of and number of connections between our neurons, is more important to our overall brain health than is neurogenesis. But I think it's a very empowering notion that we can grow new brain cells over the course of our lifespan. You brought up another molecule, another protein called BDNF. It's brain-derived neurotrophic factor. And I know you and many others have talked about this. It's kind of a miracle grow for the brain. And why is that? It's because this is a growth factor that helps our brains to form new connections. And it may even help to form new neurons, both neuroplasticity in a synaptic sense and neurogenesis. BDNF is really interesting because it's one of these molecules that we've recognized can be significantly influenced by lifestyle factors, as well as certain therapeutics. So I was recently talking on TV about this whole new idea that the serotonin hypothesis of depression may not be all that accurate. And one of the things that I brought up is that we've had this idea that conventional antidepressants like SSRIs work by increasing serotonin. But it just so happens that they also increase the molecule brain derived neurotrophic factor. And it may be that that is a better explanation for what's going on in the serotonin pathway. And I mentioned that lifestyle influences can modulate, can increase and decrease BDNF. So inflammation is thought to decrease BDNF. Stress, chronic stress, elevation in stress pathways is thought to suppress BDNF. But exercise and specific, potentially even foods, one of the examples there would be whole coffee fruit, may actually help to increase, to augment levels of brain-derived neurotrophic factor. There's also some interesting pathways related to things like omega-3s that relate to BDNF. And these may be areas that we can start making the connections between things like Mediterranean pattern diet, which tends to be rich in omega-3 fats, and lower rates for depression, lower rates for Alzheimer's disease. The bottom line I want people to take away from this, though, is that your brain is changing. Every moment of every day, it's changing. And to give you an example of this, if at the end of this sentence, you know something that you didn't know at the start of this conversation, it's because your brain has changed. Memory is a function of neuroplasticity. It's a function of the brain changing in response to environmental inputs. So it's always changing. However, it's up to us to decide, do we want to direct that change? Do we want to allow our brains to change as a reflection of what other people put in, or as a function of what we decide is best for our brains? And I would argue in the modern day, with so many people suffering from poor overall as well as brain health, unless we make that conscious decision to wire our brains for our own health, it is very likely that we're going to wind up in a place we don't want to be.
Well, I mean, I think the salient point right there is that we can rewire our brain, and that,
That's it.
I mean, fabulous. And I think you were talking about the brain neurogenesis, the ability to grow back neuronal communications and axons. And I think it was 2013, even though the data was over 20 years old. So everybody listening, you can have an impact, as Dr. Perlmutter just said, immediately if you just learned something in his last set of clinical gems that he shared with you. So BDNF, brain-derived neurotrophic factors, like you said, is a protein. Now, I'm getting a couple of blow-ups on my phone. I was hoping they would put the questions where you could read them. But number one, they said BDNF. Where does that originate from? And I think they're taking you down the pathway of the gut-to-brain axis.
You know, it's a really interesting question. Because something I learned kind of recently is that brain-derived neurotrophic factor primarily comes from within the brain, but through glial cells. What does that mean? So when it comes to talking about the brain, neurons get the spotlight almost always. We're talking about your neurons, the health of your neurons, the connections between your neurons, growing new neurons. But if you were to take out all the water weight and basically just divide up the cells in your brain, what you would find is that only half of your brain cells are neurons, and the other half are what are called glia, or glial cells. So that comes from the Greek word for glue. It was initially thought that these were cells that really just operated to hold things together. They were the glue that connected neurons. And we now recognize that that is a huge kind of oversimplification of these cells that play so many more roles. As we talk about glial cells, there's probably three that are worth knowing. One is astrocytes, and astrocytes play a number of roles. One is they kind of broker the communication between our neurons. They're involved with glutamine, glutamate, kind of uptake and recycling. They're involved with potassium signaling, and they are part of the blood-brain barrier, which is really important because you may have heard of a leaky gut being a problem, and yes, it is. But we now recognize that many of those same pathways are involved with the blood-brain barrier, that just like our gut, our blood-brain barrier can become disrupted, more permeable. And when that happens, it may be more likely that we get junk from our bloodstream, or really things we just don't want from our bloodstream getting into our brain, being able to penetrate in. So a good example there would be inflammation. We don't really want to have access between our bloodstream and our brain as it relates for inflammation to penetrate quickly. we do want to be able to detect what's happening in the bloodstream. But if our blood-brain barrier becomes more leaky, immune cells and other molecules like LPS might be able to get through that barrier and increase inflammation in the brain, which is something that we don't want to have happen. But to come back to your question, so you have astrocytes. Then number two, you have oligodendrocytes, which is a mouthful. These are cells that are primarily involved with myelinating, creating myelin sheaths over neurons to help facilitate quicker transition of signals from one end to the other. And then the third group, which is maybe most relevant to our conversation today, are called microglial cells because they're small. They're small glial cells. And these are immune cells that are seeded into the brain very early in our development. And they kind of function like a web, meaning they have all these arms and these arms kind of interlock. And so what they're doing is, in essence, sensing the entirety of your brain for signals that would lead them to either create inflammation, create damage, but maybe that's necessary if there's something dangerous in the brain, or create a number of other molecules, one of which is BDNF. And so this was a long-winded way of saying that as we're looking at ways to promote BDNF, it's not all about just keeping your neurons healthy and happy. We actually have to pay attention to these other cells, these glial cells in the brain, of which a great example is microglial cells. So how do we program our microglial cells for better health, for production of BDNF rather than production of inflammation? Well, you alluded to this earlier. There's this fascinating connection between the gut and the brain, where you have signals coming up through your vagus nerve, where you have bloodstream signals, where you have short chain fatty acids and other microbial metabolites. And these seem to be able to influence our microglial cells. So it's impossible to pull out, to tease out one little part of this system and say, well, as long as this cell is happy, the rest of you is happy. You can't say it about neurons. You can't say it about microglial cells. Just like you can't take the immune system and put it over here, then the endocrine system, then your nervous system. They are all interwoven. But what you can say is, I believe there are pretty simple lifestyle things that we can do. One example, probably the best example as it relates to BDNF, is exercise. Research has shown consistently that exercise, there's more for aerobic, but there's some for resistance training, that in humans, it increases BDNF levels in our bloodstream and in our brains. I think that's a really cool thing because it means that in a given day, if you want to amp up your brain processing, support healthy neuroplasticity, even neurogenesis, it may be as simple as just moving your body. And there's some really, really cool research showing that when you test people on measurements of executive function, which is high-level brain processing power, that it improves after exercise. And one of the reasons for that may be that exercise increases the production of this transcript for a molecule called BDNF. So you're getting kind of a very straightforward loop here, which is if you want to do something good for your overall brain health, moving your body is actually an intervention to promote healthy neuroplasticity. And understanding that damage to neuroplasticity is linked to higher risk for Alzheimer's disease and general dementias, is linked to higher risk for mood disorders, especially depression, and may actually damage our quality of moment-to-moment cognition. I mean, this is a really important thing, and it bypasses, in my opinion, all of the conversation about, oh, well, I want to exercise for weight loss. To me, exercise isn't a weight loss intervention. If you exercise without changing your diet, I'm not convinced that it actually works for weight loss. But exercising in the independence of anything else does seem to increase BDNF. So I think these are the conversations that are worth having as it relates to ways we can positively augment our brain function.
I concur with you on the exercise. You can't outrun a bad diet, as it's been said. In addition to that, that's a fabulous explanation of why you want to exercise, get moving, and just expand upon it. It doesn't mean going in a gym and having a deadlift 500 or 600 pounds or 750 burpees in 8 minutes or something like that. Steps really work. We were just away, my wife and I, and we were counting our steps. We were in Switzerland, so there was a lot of movement. So that really goes towards that. That goes towards that reprogramming like you're talking about. Got a couple of questions. Everybody jumped all over the microglials. So they're the macrophages of the central nervous system. So we've got a couple of terms I'd like you to delve into. Again, number one, we've got an M1 versus an M2 in microglials. They're vastly different. And I'd like to talk a little bit about microglial priming.
Mm. Well, let's start with M1 versus M2. Um, Generally speaking, as you know very well, Rob, when we look at the immune system, it's very complex. It's very complicated. There's a ton of subtypes of the cells that we've heard of. So you could talk about T cells, and you say, okay, well, this is a T cell. Well, not really. Is it a T helper cell? Is it a cytotoxic T cell? Then within that, if it's a T helper cell, is it a Th17, a Th1, a Th2? You can really quickly become kind of bogged down in those details. But I do think the question about macrophages, microglia, and these M1, M2 subtypes is important. And this is a oversimplification, is my understanding, is that it's not so straightforward as saying you have one or the other. But the basic idea is this. When microglial cells are at rest, when they're just basically scanning your brain for potential threats, that's sometimes called a resting or M0 microglial cell. Depending on the signals that a microglial cell gets, it is thought that it can differentiate or polarize into two major subtypes, and those are M1s and M2s. Again, this is a simplification probably of what actually happens. But imagine your microglial cell is in the brain, kind of putting out its arms, listening in to try to find out what's happening. If that microglial cell receives a certain type of signal, kind of an anti inflammatory signal, it's thought that that microglial cell will differentiate it into an M2 subtype. This microglial cell then produces things like brain-derived neurotrophic factor. It produces other growth factors, anti-inflammatory cytokines, and overall, it helps to calm down and kind of repair potential damage that is happening around it. Now, the flip side is this M1 microglial cell. Um, if a microglial cell receives a signal like lipopolysaccharide, which is a component of a gram-negative bacterial cell, it's one of the stronger inflammatory signals, and it's thought that it is a reflection of a leaky gut because it shouldn't really be in our bloodstream or in our brains. But let's say this microglial cell uh, detects this signal. That LPS is going to bind to a receptor, a toll-like receptor actually, on the side of the microglial cell, and it will turn into kind of an angry M1 subtype. So this sounds bad. I do want to say, because it's very often the case that we get into conversations about inflammation and people say, oh, inflammation bad. Well, not exactly. If there is, let's say, some damage in a cell in the brain, or let's just say there is a funky cell in your brain that really needs to be destroyed, it's damaged, or let's say there is a bacteria in your brain. These M1 microglial cells are essential. These are going to search, destroy, they're going to produce some local inflammation. They're going to eat up, given that they are macrophages, the damaged cells and eat up the pieces of bacteria. So, really important. But in kind of a steady state or an equilibrium state, it's thought that a chronic increase in the ratio of M1 microglial cells versus M0 or M2 may contribute to conditions like depression, may contribute to conditions like cognitive decline. And we'll go nerdy here for a second. There's actually a test called translocator protein staining or binding, TSPO, which you can look at on specialized imaging scans. And researchers show that there is an increase in certain parts of the brain in this measurement of M1 microglial activation in conditions like depression. So this is really nuanced, complicated stuff, but at a very basic level, the understanding is that your microglial cells are going to respond to the message they receive from their environment. And when they receive a signal, they amplify that signal. So if they receive an inflammatory signal, they're going to send off the alarm signal to the rest of the brain. They're going to say, oh, inflammation is happening. I'm going to promote inflammation. I'm going to increase the inflammation between myself and the neurons. Everyone needs to know this message. And on the flip side, if they receive that anti-inflammatory signal, that may help then to kind of quell inflammation as well as to help create new connections between neurons. It gets us to questions of what can we do to bias microglial cells towards this M2 subtype. And we're learning, it's still very much kind of cell and animal level data, But there's some suggestion that molecules like omega-3, specifically PRMs, which I know you've spoken about, may be able to help flip that switch and convert these microglial cells towards a more anti-inflammatory state. Deep dive there. There's a lot to talk about. I know the second question was about how you prime your microglial cells, maybe early life influences on them, but I'll pause here for a second.
Yeah, deep dive. Definitely. We got a lot to get through. That unleveling of the microglials, M1 and M2, is a very deep, heady topic. You did a great job of breaking it down. Blew up a lot of questions, but I think maybe the key point through it all was you said inflammation isn't a bad guy. The problem with inflammation is it runs too high or it runs too long. And obviously, inflammation in the brain running too high or too long is damaging to overall brain structure. And maybe we could tie it back into the blood-brain barrier, which I've always called the doorway to the brain. So most people talk about these barriers being critical elements for overall health. However, the blood-brain barrier is an interesting barrier in that it's made up of the same proteins as the gut, but again, it's there to protect the brain. Some blood-brain barrier tests we all know can damage the blood-brain barrier, can portend these neurodegenerative diseases that you alluded to. I got a ton of questions for you. So let's get into the questions because everybody's watching. And I guess the microglia is a thing that woke them up. So Vanessa would like to know, is carbs or fat better for brain performance?
I mean, that's a great question. There's going to be a very strong debate on both sides of the spectrum here. The main conversation here seems to be about not carbs necessarily, but the utilization of the energy source in carbohydrates, which is glucose. If you take a carbohydrate and break it down to its kind of core elements, one of those is glucose. And it is true that the primary fuel source used by our neurons, which are the primary energetic users in the brain, is glucose. It's just as a little aside here, it's interesting to note that the brain is only a couple percent of our overall body weight, but it can run between 20 and 30% of our overall energetic need. So it's incredibly energy dependent as it relates to how much fuel it needs to function. And when you look at what is using the fuel, it's neurons, because neurons need energy to transmit signals between one side of the neuron and the other, to repolarize after they depolarize. And if you look at a brain that is in use, so basically a PET scan, which is looking at glucose use in the brain, you'll see that areas of the brain that are being used actually are using up more glucose. So there's a really fascinating scenario here, which is based on what you're thinking about or how you're using your brain, you're actually preferentially engaging certain neurons and using up certain amounts of glucose for those neurons. So the question often comes up, I've heard carbs are bad, and so don't we want our brains to run on ketones? It's a good question. A lot of people are out there saying, oh, ketones are a cleaner fuel. I think for most people, most of the time, we're running on glucose for our brains. I think that there are scenarios in which we can use some ketones, but I'm not convinced that we are flipping a switch and our brains are simply running on ketones. And again, that's because glucose does seem to be preferentially the fuel source used by the brain in most instances. Now, there's a couple of interesting caveats to the conversation about glucose in the brain. One is that chronic consumption of carby foods, and I use that very generally, but really simple carbohydrates. What that means is it's carbohydrates that readily break down to glucose and lead to rapid spikes in our blood glucose levels and subsequently lead to our production of a bunch of insulin in an attempt to try to chase that glucose down. These are the things that come before the development of insulin resistance, which comes before the development of prediabetes, which comes before the development of diabetes. And it has been pretty clearly shown that in instances of glucose problems, of which all of these are a form of that, there's a correlation with issues with brain function. I've been looking a lot recently at correlations between hemoglobin A1C, which is kind of a multi-month indicator of blood glucose levels, and things like depression and cognition. I haven't been so convinced that it's the A1C itself. Rather, it seems like it's the variability, which means how well is your body able to respond to glucose? Does it shoot up and then plummet low? And the reason for this, for me at least, is that the brain needs a consistent supply of glucose. And even though often people will talk about insulin and its key role in the brain, that is definitely a case. The majority of our glucose transporters that get glucose into the brain are insulin independent, which means you're basically looking at a reflection of your blood glucose going into your brain. And so, because your brain is so energy dependent, I would think that having consistent glucose rather than super high, super low spikes is probably a good thing. And the other thing is, there is a strong correlation with A1C, hemoglobin A1C, as well as pre and full on diabetes and inflammation. So, why that matters is in part that inflammation in the bloodstream may damage the blood brain barrier. So, if you're increasing inflammation by way of metabolic issues, that inflammation may increase permeability of your blood brain barrier, subjecting your microglial cells and your brain cells to increases in inflammation, which isn't good for anyone's brain or anyone's brain cells. Um, but let's go back in here for a moment. So, too much carbs, too much unhealthy carbs linked to things like insulin resistance, glucose issues, diabetes. These are things that are linked to brain dysfunction, yes. One of the correlations that's been seen with Alzheimer's disease primarily is that there are issues with glucose use in the brain, that the brain doesn't seem as able to get access to glucose, meaning if you were to look at how much glucose it seems to be using, what you have is cerebral hypometabolism, lower rates of metabolic use than what you would see in a healthy control. And so that's where there starts to be a conversation about what's called central insulin resistance. Now, again, Rob, we can pull back here if we're getting too technical, but we often talk about insulin resistance as something that happens kind of in the body, meaning our tissues have a hard time sensing insulin, and therefore we have higher blood sugar, we have more insulin in our bloodstream. Um, these are things that lead to things like advanced glycation end products, which are inflammatory proteins that get tacked on to our cells, or I should say inflammatory additions of carbohydrate that could attach to our cells. But the main point here being that if our brains have more trouble using glucose as time goes on, that seems like it could be linked to worse cognition. And that's where you get to the point of where I believe we probably should be having the conversation around interventions like fat for brain health, because what has been shown is that even in people who have this cerebral hypometabolism, meaning they have something like Alzheimer's, they seem to have a hard time leveraging that glucose in the brain, that ketones are able to get into the brain and help power it independent of that glucose. There's a number of reasons for that. Probably the best one is they use different transporters. It's just a totally different system of uptake. But I'm not convinced that for the average person, there needs to be a whole lot of concern about either taking exogenous ketones or trying to stay in ketosis as an intervention for brain health. I haven't seen much as it relates to improvements in cognition in healthy people when they create interventions to flip over their brain metabolism from glucose into more ketones. That still to say, I do the best I can to keep my blood sugar leveled. I have used CGMs in the past. And I do think that for most of us, you know, starting with the carbohydrate that almost all of us are getting too much of, which is added sugars. And that's in theory a range of carbohydrates, but fructose, glucose, these are things that we probably want to pay attention to. So I think looking out for added sugars in any form, as well as trying to minimize the consumption of simple carbs, maybe not the best term, but carbohydrates that readily break down into simple sugars, and that's basically your white starches, is a good intervention for overall health as well as for brain health, in part through the mechanisms I just discussed.
So we want to avoid the simple, crappy carbs. We want to eat the good quality fats. And here comes the pressing question. Fructose. What effect does fructose have on the brain?
Yeah, so that's a really good question. Maybe it's one best suited for my dad. He just recently put out a book called Drop Acid. Um, so fructose is really interesting in that it doesn't trigger insulin in the same way. It doesn't trigger satiety hormones in the same way that we might get from just glucose. It seems like there's a couple of pathways that are worth knowing. One is that fructose may more quickly contribute to liver fat and storage of triglycerides than does glucose. The other one is that fructose kind of metabolism produces this byproduct uric acid. And uric acid, even though it is the most prevalent antioxidant in our bodies, is linked to a number of problems, a number of diseases. And so there has been a conversation, again, my dad is a big part of this, talking about why we need to pay attention to our fructose intake, both because fructose itself seems to have these kind of unhealthy metabolic effects, especially through the liver, and because of this breakdown product, uric acid, which kind of triggers its own cascades of negative effects. As it relates to brain health, I think you kind of quickly get back to these same mechanisms of kind of overall insulin resistance, liver fat, and the correlations between metabolic dysfunction and brain dysfunction, with the understanding that the brain is not separate from the rest of the body. And if you start developing issues with processing of glucose and insulin in the periphery, at some point that will trickle into the brain, either through a pathway like inflammation or directly through the brain's access to glucose and its relative degree of insulin resistance. So everyone has a slightly different perspective on, is fructose terrible? Is it the worst sugar? I think that we are still learning exactly the effects of fructose, how they differ from other sugars. I don't think that there's a scenario in which anyone should be prioritizing something like high fructose corn syrup over other types of sugars. That doesn't make any sense to me. But on the flip side, there, people will say, "Oh, well, there's fructose in fruit, so should I avoid fruit?" And as far as I can tell, if you're not choosing something that has been hugely modified by, basically certain types of agricultural practices so that it's a sugar-packed fruit, um, I don't have any major issues with people eating whole fruit because of, as you know well, the matrix, the fiber, the phytonutrients, the other nutrients that are in there. Um, but yeah, I think as it relates to correlations between fructose and specifically brain health, I would go with those two answers. One being fructose intake is correlated with overall metabolic dysfunction, which when correlated with brain function is not great. And two is it may increase inflammation through a variety of pathways, and inflammation in our bodies may translate into inflammation in our brains. Inflammation in our brains is correlated with basically every brain disease that is, among the top 10 brain diseases on earth right now, from mood issues to cognitive issues, dementias, and the like.
So whole fruits, lower glycemic index, good. Fruit
I,
juice is no bueno.
I don't touch fruit juice, even though when I was a kid, I was drinking apple juice every day. And I think it was only the cavities that led my parents to say, maybe
How
this
funny.
isn't the best thing. But in the spectrum here of value to us, the more a food has been processed for palatability, and in that I would put fruit juice, because you've taken out all of the fiber, all the mash and stuff that was part of the fruit, the less benefit it tends to be for our health. And I know that's sometimes an affront to people who are talking about, I'm going to juice these or press these fruits and vegetables and take out that extract, the super nutritious stuff. Um, I am convinced, increasingly convinced, that nature knows what it's doing. And the more we try to mess with that in an effort to be more efficient with how we eat food or drink food, the less benefits we're actually getting from consuming that food.
If man makes it, I won't eat it. Famous Jack LaLanne once said
Mm-hmm.
that. We've got loaded up on questions, so we'll get into that rapid fire
Great.
mode. We got some really good questions for you. They're not in order. Sometimes it takes a while, but let's try Jennifer's. In addition to exercise as a brain benefit boost, what does your research reveal about mindfulness and meditation on brain health?
Yeah, it's a great question, Jennifer. You know, as I look at the things that we can do to improve our brain health and to improve our brain's immune health, I think there's two things you want to pay attention to, and both relate to what we consume. So we've talked a good amount about the food, what we're putting into our mouths as a central player in our overall health and our brain health. But something that people are not as conscious of is that what comes in directly through your eyes and ears, through your sensory organs, is going to change your brain state. So I've talked at length about the idea that people today are spending 11, 12 hours a day in front of their screens, 4 hours a day watching TV, about 2 to 3 hours on their phones, on social media. And all of that, it can be helpful. It can be beneficial to your business. You can be learning, you can be connecting with other people. But a lot of that is stressful and mindless consumption of media. Um, what we know is that stress is probably one of the most toxic things for our brain function. It disables healthy neuroplasticity and neurogenesis. It leads to neuroinflammation. It disrupts healthy cognition. It separates the prefrontal cortex from the more limbic areas of our brain. So it's not a good thing. On the flip side, mindfulness, which is the opposite of mindlessness, has a bunch of research to support its benefit. It's a little hard for me to tease out whether the benefit comes from not being mindless or from being mindful, but maybe it's not all that important. I think for the average person, taking time off of mindlessness, especially stressful mindlessness, and instead closing your eyes, meditating, practicing paying attention to your breath, engaging in activities that force us or allow us to pay attention to what's happening inside. These are things that have been shown in studies to lower stress levels. They are also things that have been linked to lower levels of inflammation. And one of the things that we talked about, my father and myself, in our book Brainwash, is that mindfulness interventions, meditation, mindful time, is correlated with neuroplastic changes in the brain that can be observed on imaging. One of the more notables is that it seems to help integrate the higher levels of thinking, the part of your brain in the prefrontal cortex, with the limbic system, which is the more emotional, a bit more impulsive parts of your brain. So I am a big fan of mindfulness meditation. I try to do daily meditation. I also like to do mindfulness in nature because nature has its own kind of host of benefits. Um, I don't think you're going to find anyone out there who's going to say that meditation and mindfulness is not good for your brain health. But I also believe that it doesn't make sense to make this blanket statement that everyone needs to spend an hour on their couch or on their cushion with their eyes closed. Instead, I think there's two ways you can get to this. One is by carving out time for mindfulness time. The other one is to take in less mindless time, and specifically stressful mindless time. So for the average person, I believe it is a bigger benefit to their brain health to cut back on news exposure than it is for them to be meditating for 20 minutes in the morning. And the reason is that science is solid. Stress increases brain dysfunction. What happens for an individual when they close their eyes and try to meditate is a bit more variable. So I say start with the low hanging fruit. And that is, if you're consuming media that is stressing you out, try to cut back there first. If you're willing to incorporate some mindfulness time as well, fantastic. If you want to just go straight into mindful breathing, meditation, other forms of mindfulness, that's great too. But the correlation again between stressful media consumption and worse brain health is pretty solid. So I tend to tell people to start there.
Fabulous. Yeah, I want to mention to everybody, you alluded to a couple of books. Number one was Brainwash by your dad and yourself. So that would be David and Austin Perlmutter. Great read. Have a copy. Strongly recommended. And your dad's book, Drop Acid, which is the best cover I've ever seen. Great book. Definitely a revolutionary approach to what concepts of uric acid and fructose's effect on uric acid. Get that cherry.
Plug for him.
Yeah, wow. My favorite, without question. Great stuff. Your dad also has some other books. Dr. David Perlmutter, without question. The leading functional medicine neurologist, as far as I'm concerned, in the world. Does a great job empowering neurologists on his website if anybody's interested. I'm going to get these questions. I try to do it like a little interview style, and they're asking some good questions.
I'll do quicker answers. Mood boosting
tips.
TOs. Well, unless we're talking about what is that? Uncles in Spanish, probably tips is what we're referring to. So that's a great question. The big things would be one, as I said, cutting out excessive stressful media consumption. I think that's really big. Um, Sleep is absolutely huge. Prioritizing sleep is really important. So it's interesting. Cutting your sleep short increases BDNF acutely, but when we're talking about long-term benefits to our brain health, it's really a consistent sleep, getting 7 to 9 hours a night and prioritizing that over other stuff. I think that's absolutely essential. Sleep issues have been correlated with just about every brain health issue. As it relates to dietary stuff, I know that's a popular one. I've been writing about this a lot. I think as it relates to the correlation between mood and diet, the strongest research is in the connection between depression and diet, and the strongest dietary correlation with depression, as far as being a depression intervention, is the Mediterranean diet. And so, why is that? Well, Mediterranean diet is one that is very low in processed ingredients. It's low in added sugars. It's high in plants that are rich in polyphenols, which are molecules that help plants defend themselves against stress and are thought to influence our health, our immune health, our overall wellness, as well as our gut health. So, eating a variety of colorful fruits, vegetables, spices are really high in polyphenols, coffee, tea. One of my favorites, and Rob, I know one you've experimented with, is Himalayan Tartary buckwheat, which is a plant that is
Absolutely.
especially high in quercetin, rutin, hesperidin, and luteolin, all of which are polyphenols. Um, then I would say eating foods that are rich in omega-3 fats. I mean, this is maybe one of the points that everyone kind of knows at this stage, which is omegas are kind of essential to healthy brain function. Most people aren't getting enough omegas based on data that is kind of outside of the realm of integrative medicine. This is kind of well established, just people are not getting a good amount of that. So eating the smash food, Rob, I saw you posted about this kind of recently, prioritizing fish that are low in mercury, high in omega-3 fats, salmon, mackerel, anchovies, sardines, and herring. That's the mnemonic for smash. And then I think prioritizing gut health, which is its own separate topic, super important, obviously. And the way that I try to do that is eating a range of fiber rich foods. Polyphenols are actually great for gut health too, but there's certain fiber in foods that have been linked to a prebiotic effect, which means that they seem to be especially good for the microbes. Um, there's a range. Some of these are esoteric. It'll be, Jerusalem artichoke. I don't have those in my grocery store. I'm not eating a ton of Jerusalem artichoke, but what I do eat is onions and garlic. Those are rich sources of prebiotic fiber. They're also rich in polyphenols. Garlic has a nutrient called allicin, which is kind of a cool one to look up if people are interested. And I use that as kind of a base for most of my cooking, both because I like the flavor and you're getting that fiber. Other ones, jicama, if you can find it. I love it. Dandelion greens. And then just generally, I mean, I think as it relates to overall health, nature exposure, I'm really big on that because in the spectrum of things that are cost effective and generally effective, exposure to nature has been correlated with lower levels of stress, with better subjective mental health, with better overall health. And it's kind of the antithesis of what we're spending our time doing today, which is engaging through screens and being inside. So, if people are able, I know that depending on the season, it's not always super practical, but right now it is September 6th. And so, at least in the Northern Hemisphere, for most of North America, you have fall coming up. Get outside, spend a little time off your screen. That's a great intervention for mental health, and it's free.
Fabulous. So I have a question right up your alley, tailor made for you. Thank you for this very informative discussion. Neurotransmitters. What is the impact on mood and brain function?
Great. Neurotransmitters, neuromodulators, there's a big family of different molecules. The ones that people are most familiar with are the monoamines. So we're talking dopamine, serotonin, norepinephrine. There are a number of other ones, but I think for the sake of this, those are the ones to focus on, with maybe the exception of glutamate. It's always kind of an important one too. But point being here, when signals go from one neuron to another or between glial cells and neurons, they use these chemical messengers called neurotransmitters. Um, for a long time, and I would argue still is the standard of our thought, we have considered that neurotransmitters are responsible for mood issues, specifically thinking about depression here being an issue with serotonin. So, serotonin is a monoamine as far as the chemical structure. And for the last 50 plus years, the dominant theory of what drives depression has been that there is an issue with our serotonin function. There was a paper that came out last month in Molecular Psychiatry, which is a Nature publication, that in essence called into question whether serotonin has anything to do with depression. Looked at a bunch of different studies. It was an umbrella paper or an umbrella review. So it looked at a whole bunch of meta-analyses, and it said there's really not a strong link. Where I fall on this is that neurotransmitters are absolutely involved in basically every aspect of brain function, but probably not in the way that we think. It's not so straightforward to say if you just increase your dopamine, increase your serotonin, blank will happen. On the flip side of that, something that I alluded to earlier is that our immune system in our brain changes levels of neurotransmitters. So in the context of elevated neuroinflammation, the tryptophan in our brain gets shunted away from production of serotonin and instead turns into a number of other metabolites of a pathway called the kynurenine pathway. Why does that matter? Because some of those pathway metabolites seem to be promoting healthy brain function, and some of those metabolites seem to be neurotoxic, quinolinic acid being the prototypical example, having effects on our brain function and maybe having this neurotoxic effect. So this is all very technical, but the basic idea here is that it's not so straightforward as saying, well, it's just a neurotransmitter issue. All of these systems are interconnected, but yes, neurotransmitters are involved. It's just not the whole story as it relates to our brain function.
You'd mentioned Himalayan tartary buckwheat, and that's from Big Bold Health. And you are the science director. Could you tell us a little bit about what's going on with that very interesting ingredient that I love to make into my pancakes in the morning?
Yeah, well, thank you for that. So our mutual friend, Dr. Jeffrey Bland, father of functional medicine and researcher and just overall really smart person, I think he's always been looking for ways to make health more accessible. And he is kind of the type of person who gets super, super interested in the research connecting various foods with health outcomes. And so he, like many of us, has been interested in this topic of polyphenols, these plant nutrients, for some time. And through a range of experiences, he had this realization that there was this plant called Himalayan tartary buckwheat, which, number one, is not a wheat, it's a fruit seed. Number two, isn't all that related to common buckwheat. It only shares about 40% of its genes with that plant. And three, is about one of the richest sources of these polyphenols like rutin and quercetin, luteolin, hesperidin. And so he, in his prescience, decided to invest in and become a part owner in these farms where they're producing, at the moment, the United States only organic certified Himalayan tartary buckwheat. And so we at Big Bold Health have done a lot of work with this. One is just we made the flour available. It's a really fun flour to cook with. It sounds like you've enjoyed it too. I really like the pancake recipe, but I've messed with a bunch of other stuff too. It's a great way to use a gluten-free, low glycemic impact flour in place of what we usually would eat, which is wheat, and usually is pretty junky. But the other area that I've been especially involved with is Jeff wanted to know, what impact do these polyphenols, these phytochemicals, have on our health, and specifically on our immune health? And so we're in the last stages right now of wrapping up a study which is looking at the impact of the phytonutrients, the polyphenols from Himalayan tartary buckwheat, on markers of immune aging. So we're looking at a topic called immune aging, how our immune system changes as we get older, how that relates to things like inflammation, using some pretty complicated tests. But when this is done, it will be one of the first instances of kind of a deep dive into the connection between these plant nutrients, polyphenols, and the immune system in people, as opposed to kind of lab-based tests that tend to be done with cells or with animals. So that'll be really interesting. We're just, as I said, in the final stages of this, with the expectation of hopefully having some results in the next month or two.
Great stuff. Yeah, Big Bold Health. We're big friends with them, though, pun intended. The show notes, anybody who's interested, you'll be able to get Dr. Perlmutter's book, Brainwash, his dad's book, drop acid, and we'll do a link for a Big Bold Health. So
Fantastic.
essentially, a lot of people asked, how can I get in touch with you after this podcast?
Well, it's a good question. The two easiest ways would be one, my Instagram, which is Dr. Austin Perlmutter, and the other one is my newsletter that I've been trying to be more regular with, but I'm pretty consistent.
It's hard.
Newsletter focuses on all the things we discussed today, brain related, and you can find that on my website, which is austinperlmutter.com.
Fabulous. Well, Dr. Perlmutter, Austin, it's been my pleasure. Thanks for coming back on. Always illuminating, sharing a plethora of different items that are implementable on Monday morning, which is a key element. I thank you so much. You are without question in fuego, on fire. I mean, you are, wow. Whew. I mean, your trajectory is great. It's just an honor to share some space with you. And hopefully we can get you back on when book number 2 comes out. Hint, hint.
Sounds great, Robin. Thank you for having me. Congratulations on all your work you've been doing. Amazing stuff as well.
Thanks so much, everybody. Dr. Rob Silverman, Dr. Austin Perlmutter, Proven Health Alternatives.